We had a snow day last Thursday. Schools were closed, stores were closed, so I stayed home and made this. This is a prototype box to hold a 0 to 1 inch depth micrometer. Welcome to Power Forging Workshop, where I work with metal, with wood, with CNC, with the analog approach of blacksmithing. And last week I worked with Fusion 360 to design this box to hold my depth micrometer. So let me take you into 360 and I'll show you how I did it. Okay, so I actually had a model to work off of. So I took some major dimensions from the box that it came in. It came in a styrofoam box, which was in a cardboard box, and I really hated it. After a few weeks, the styrofoam was starting to come apart and fall apart, and I really wanted a wooden case like my other tools are in. So I modeled this off roughly of the same design they had. I did add this different design. In the bottom, you'll see here, I put a hole. And that's actually so I can get the micrometer out easier. Check this out. There's a little hole here. Just push, comes out really fast, really easy. So yeah, so I put that hole in. A couple slots for manuals or whatnot. They had it in their original box, so I kept that. Yeah. So it's roughly 6 1/4 inches long by about 2 7/8 wide. Okay. And I modeled it at 1.5 inches tall, so I could make this prototype out of standard pine, out of a 2x4 or 2x6, or you know, I've got a lot of scraps laying around that made it easy. If we go play by play, this is kind of how I did it. Extruded it, created a sketch, made more extrusions, more cuts, and made that model. The top, there's a tolerance fit that goes around this lip here. Here is the top, and it has an indent, or when you extrude and cut into the material, which allows space for the bezel. I did the cam on Fusion 360 as well. The day before, let me go into manufacture here. The day before, I set up the machine, the Shapeoko here. I've got a Silex 7 in here, and I got the Shapeoko machine set up. And I went ahead and set up a good tool library of all of the bits we have to use with that. If I do this again or make a nicer one, the down cut's nice for the initial milling into the wood, because it creates a very crisp edge on the wood, as opposed to an upcut. When you cut into that first cut, it brings up little burrs, little chips of wood, and it doesn't look as nice. Conversely, an upcut is going to look a lot better at the bottom of your pocket here, whereas the downcut, the flutes come down, and actually the center is a little exposed. The flutes protrude farther than the center, so it leaves a little rough finish, and you can see the end mill. So yeah, so basically all I had to use was this 1/4 inch downcut end mill. Again, in the future, if anyone wants one of these, some guys at my school might want one. I would use a upcut end mill for the bottom of the pockets, and then I would put a nice little chamfer in there just to make things smooth. All right, so as far as my tool paths, I did the main pocket, as you can see there. I did the through, that was my second tool path, the lip, and then the exterior with these tabs. These tabs were roughly 8 millimeters wide by 2 millimeters tall. I gave you inch dimensions before, but I did this entire project in the metric system, because when I'm going to be milling on the big CNC vertical machine mill, the SILE, I want to do everything in metric. I just prefer that. All right, so let's see. Let's stimulate this. Joke, simulate. I always say stimulate. I just think that sounds better. Here's the main pocket. There you go. There's the perimeter. And, oh yeah, that's right. I actually, in the middle of this process, I was doing these pockets. I did these pockets here, but unfortunately, I had everything on a helical ramp down, and it was taking forever for it to ramp down, and in softwood, you don't need that. So I came back out here, removed these 2 slots from the G-code, and then reprogrammed this with a plunge and feed in, which made the operation much quicker, which is okay for wood. As far as feeds and speeds go, well, let's take a look here. I gotta close this. Most of you, well, all right, so I'm running a 1/4 inch end mill. Typically, the inches per, or the millimeters per minute on this 1/4 inch end mill, we're running at 2.54 millimeters per minute. Here's the surface speeds in meters per minute. There's my geometry selected. I'm running in multiple depths. I would like to try this again at, this is 2.54 millimeters, which is about, what, 0.1 inches. I'd like to go the full 1/4 of an inch, or the full diameter of the end mill down, and try that and see if it'll work. I think this could be a little more aggressive. And then, yeah, keep cool down. Otherwise, Fusion wants to pop that thing up every time it does one of these multiple depths. That speeds it up. And speaking of speed, let's take a look at the machine time. Total machine time, 11 minutes. So probably with the other parts, it's probably about 13-15 minutes. Pretty good. So, all right. Oh, I'm going to show you some fast-forwarded clips of the actual milling. But before I do, at the end, stay to the end, and you'll see our screw-up. I tried to first do this out of oak, because I had a good piece of oak in the dimension, and it was a bit of fiasco. And I'll show that to you after the end. All right, there you go. All done. What do you think? It was a lot of fun for us. Again, thanks for staying to the end, as I promised. I'll put some stills on the screen of this and this as well. This is that oak piece I talked about. Again, this is just a prototype, figuring things out. The finish on this oak is absolutely fantastic compared to this crappy pine. It's a lot heavier though, so ultimately I think a lighter box would be better, but you can see it started its cut here, and then it was quite an aggressive ramp. I was doing I can't remember now, I think it was a ramping procedure where it was doing a spiral ramp instead of by depth, and then the bit came out of the collet and started just falling and cutting and falling and cutting. You can see how it's getting lower and lower and lower, and then it just fell out and just tore it up. My first crash. So anyway, so this concludes my first video from start to finish, getting a concept, getting something that I wanted to design it in Fusion 360, run the CAD, run the CAM, then go out into the shop and make it, prototype it, test, experiment, and ultimately succeed. And I think we did that here today. Thanks for tuning in. Talk to you later.